I added some files to the program so I can start adding some code, and I'm kind of working backwards at this point. So I had the code to render a sprite. I'm just splitting that up so I can render a sprite with data defined in a renderable sprite component. So just by taking the code that I'd already written, I started to identify what information I need to render the sprite. So I'm only going to supply the absolute bare minimum data that I need in this function. And that highlighted some things that I'd missed out, like I'd forgotten about input layout and potentially some other things. With these sprites, I could optimize them because they don't necessarily need to have vertex shader and pixel shader IDs that are different at the moment. They use the same shader and the same texture, for example. But in the future, the worst case might be that I need different vertex shaders and textures for a sprite, so I'm kind of doing the worst case scenario first, and then I'll optimize it for the data I have when I start making the game properly. This is just to kind of cover the sort of the full approach. I'm having to add some sort of debug code to just add entities. Like I said before, I'm working backwards from the data, so at this point I know I need to create sort of render states, shaders, and all sorts of things like that elsewhere. But I know I can use them in the render sprites function, so at the moment I've just got some functions to create assets and data that I need, and then it means I can just focus on the rendering sprites and the updates and things like that, and later on I'll come to look at the data I'm creating these objects from and how to maybe derive that data from outside of the game in script files or config files or something like that. But one thing I do quite like with having done the renderer the way that I did is I can create these clear states or blend states and just have these sort of global ones, like additive blend or alpha blend or clear black, and you just, when you're writing render code, you've got access to these global states, and you're not having to actually write that much code. And it's also more efficient because you're just setting the blend state in one go instead of building it up in little bits and pieces. So an example here is that the file name for the shaders currently is hard coded, and at some point in the future that would have to be defined in some data file maybe, or something like that. But for the time being, I'm not going to worry about that. I'm just going to create some shaders in code, and then, like I say, come back to it later. I think what I'll do, I'll write something in the utility toolkit to load shaders and also generate input layouts, because after this I started to look at something else and wanted to add a shader, and it is a bit of a pain. It's just a lot of typing to fill out those input layout structs. And also, yeah, I'm creating vertex and index buffers just in a function here, and again, I'll probably add into the utility toolkit some functionality to generate primitive vertex buffers. So do quads, but also cubes and spheres and cones are always useful to have. So here I've got like a render scene function, that sort of clears the back buffer, sets up the blend mode, and then it renders some sprites. In the future that might do multiple render passes if it was doing deferred rendering or shadow maps and things like that. And then the render sprites function is just to make a draw call based on the renderable component. Just having to add here into pre-make the include directory. It was quite a lot of work to move all this stuff over because the sort of monolithic main function in the game thread that I was previously using had got quite big, because it was just a dumping ground to test all of the engine functionality. So this is kind of just refactoring it into more of a nicer setup for writing a game around it.